The tendency of an element to form a cation by losing electrons is known as electropositive or metallic character. This character depends upon the ionization energy. Generally, on descending a group, the ionization energy decreases and the metallic character increases. In p-Bock, the elements present in the lower left part are metals, while the elements in the upper right part are called non-metals. Elements of group 13 have metallic character except the first element, carbon, which is a metalloid, having properties intermediate between the metal and non-metals. The atomic radius of boron is very small and it has a relatively high nuclear charge, and these properties are reasonable for its metallic character. In the subsequent groups, the metallic character increases. In groups of 14 elements, carbon is a non-metal while silicon and germanium are metalloids. In group 15, nitrogen and phosphorus are non-metals and arsenic and antimony are metalloids. In group 16, oxygen, sulfur and selenium are non-metals and tellurium is a metalloid. All elements of group 17 and 18 are non-metals. Ionization enthalpy. We have already learned that as we move down a group, generally there is steady decrease in ionization enthalpy of elements due to increase in their atomic radius. The p-Bock elements, there are minor deviations to the general trend. In the group 13, from boron to aluminum, the ionization enthalpy decreases as expected, but from aluminum to thallium there is only a marginal difference. This is due to the presence of inner d and f electrons, which has poor shielding effect compared to s and p electrons. As a result, the effective nuclear charge on the valence electrons increases. A similar trend is observed in group 14. The remaining groups 15 to 18 follow the general trend. In these groups, the ionization enthalpy decreases as we move down the group. However, here poor shielding effect of d and f electrons are overcome by the increased shielding effect of the additional p electrons. The ionization enthalpy of elements in successive groups is higher than the corresponding elements of the previous group as expected. As we move down the 13th group, the electronegativity first decreases from carbon to boron to aluminum and then marginally increases for gallium. Thereafter, there is no appreciable change. Similar trend is observed in 14th group as well. In other groups, as we move down the group, the electronegativity decreases. This observed trend can be correlated with their atomic radius. Anomalous properties. Anomalous properties of the first elements. In the p-Bock elements, the first member of each group differs from the other members of the corresponding group. The following factors are responsible for this anomaly: small size of the first member, high ionization enthalpy and high electronegativity, absence of d orbitals in their valence shell. The first member of the group 13, boron, is a metalloid, while the others are reactive metals. Moreover, boron shows diagonal relationship with silicon of group 14. The oxides of boron and silicon are similar in their acidic nature. Both boron and silicon form covalent hydrates and that can be easily hydrolyzed. Similarly, except boron trifluoride, halides of both elements are readily hydrolyzed. In group 14, the first element, carbon, is strictly a non-metal, while other elements are metalloids. Silicon, germanium or germanium are metals, tin and lead. Unlike other elements of the groups, or carbon can form multiple bonds such as C double bond C, C double bond O. Carbon has a greater tendency to form chain of bonds with itself or with other atoms, which is known as catenation. There is considerable decrease in catenation property down the groups. In group 15, the first element, nitrogen, differs from the rest of the elements of the group. Like carbon, nitrogen can form multiple bonds, N double one N, C double one N, N double one bond. Nitrogen is a diatomic gas, while other members of the group similarly unlike other members of the group. Similarly, in group 16, the first element, oxygen, also exists as a diametric gas, and due to its regular electronegativity, it forms hydrogen bonds. The first element of group 17, Flourine, is the most electronegative element, also behaves quite differently compared to the rest of the members of the group. Like oxygen, it also forms hydrogen bonds. It shows only -1 oxidation state, while the other halogens have +1, +3 and +5, +7 oxidation states in addition to -1 state. The fluorine is the strongest oxidizing agent and the most reactive element among the halogens.